So James he's currently Secretary for the Environment and Chief Executive of the Ministry for the Environment. Prior to that, he was Chief Executive of the Hawke's Bay Regional Council, and prior to that, James has held senior roles in just about every government department that there is, including MPI, EPA, the Environmental Protection Authority, the Ministry of Ag and Forestry. He's been private secretary to 2 or 3 different ministers. So there are not many people who know as much about the workings of central government and local government as James does. As you will no doubt see in a minute, he also speaks incredibly well off the cuff, and we're delighted that he's made time to be with us today. There he is.
Kia ora koutou. Thanks, Robin. Thank you for your kind introduction. I'm slightly relieved that you didn't suggest that I may have some expertise in farming or growing. So the first disclaimer is that that's absolutely not my gift. And so I do come to you from the perspective of a public servant and a policymaker as opposed to a technician. So it was lovely to listen to Dan just now talking about the the realities of doing practical stuff on the ground. And great to see that project having made such great progress. So folks, I was asked to speak to you to give a government perspective, and I've got a confession, and I'll just share my screen here so we have a presentation to speak to. I'll just start sharing. Right, you can see that. Is it running as a slideshow? There we go. Fantastic. And look, the confession goes like this. We're currently in caretaker mode as a government. So we're between one government going out the door and one coming in. And therefore, articulating what is the government's position on anything is a fraught task at this moment in time. So I'm not here to speak to you today about current government policy or where the last government has finished off and where the next one is picking up. And so with that, I thought I would take the opportunity to give you a bit of a personal perspective. And as I was thinking about that context, what struck me was about a decade ago, I was asked to speak at an event just a few hundred metres from where you are at Toitoi now, at an event that the Hawke's Bay Regional Council had run on East Coast farming resilience. And it was the focus was very much on soils, and we were talking about the importance of protecting our soils, of soil erosion, soil biology, soil health. And at the time, I seem to recall speculating that the practice of digging up phosphate rock from the Western Sahara, shipping it across the world, crushing it up and spraying it over our landscapes by aircraft probably wasn't something that would endure to the end of the century. So I had the privilege during the last decade of working within the Hawke's Bay Regional Council, as Robin has mentioned, working with our communities and growers on the challenge of sustainable land use in Te Matua Maui, Hawke's Bay, and in particular our soil conservation challenges. And I was really privileged to be able to be part of an effort by the Regional Council during that time to scale up the work that it was doing on land management, soil conservation, and also work around the river control and flood infrastructure. And look, that was also important because it was framed in the context of the coming changes to our climate. And so it was a particularly distressing, sobering, and frankly, quite traumatic event for many of us, myself included, 3 days after I finished at the Hawke's Bay Regional Council for Cyclone Gabrielle to arrive and to witness the extraordinary destruction of that on the region and on our landscapes, and to have the work that we'd been doing on soil conservation, on sustainable land use, on water quality, and on flood protection be put in the context of a real live event. And I'll be honest and say that it was the worst nightmare a regional council chief executive could have when you're responsible for regional civil defence, regional flood control, and you see the efforts of many decades of work around soil conservation result in vast amounts of sediment flowing down into our valleys, causing the destruction they did along with the floodwaters, and then ultimately so much out to sea. So it's really with that perspective that I wanted to speak to you today. And look, to state a little bit of the obvious for the audience, agriculture is the foundation of our society, and soils are the foundation of agriculture, but it all still depends on a stable climate. And so I didn't think I could offer this audience any particular insights into the technical business of growing soils, of caring for soils. But what I did think I could talk to you a little bit about is the climate backdrop and its intersection with our landscapes and our land use, as I see it right at this point in time. So, of course, climate change is here and now, and recently we released the latest temperature data, which we report on with Statistics New Zealand, which shows that since 1909, the average temperature in New Zealand has increased by 1.26 degrees. And the 8 of the 10 warmest years have been in the last decade. Last year was the warmest on record. This year is shaping up to potentially be the warmest again. And the point I wanted to make about that is that climate change is accelerating. It's not linear, and what we're seeing is an acceleration in those temperature increases. Of course, it's not just about temperature increases, it's also about changes in precipitation. And we know that looking at the trends, 1960 to 2022, there are parts of the region of the country where there's a definitive shift either to more rainfall or less rainfall. And so it affects different parts of the country differently. And so it's complex at that level. It's not just about overall temperature increases, it is changes to the distribution of precipitation and changes to our weather patterns. And obviously that can have impacts on more severe events, particularly as more energy goes into the ocean, with the ocean warming much faster than the atmosphere, and warmer atmosphere, greater moisture, and more energy being in the cyclonic systems, which can come further south because the ocean is warmer to lower latitudes than it was historically. And so while we had a very severe event in 1938 that was very similar to what we experienced earlier this year, and many of the conditions are similar, what we do know is that the severity of these events, which have always happened, will be greater, and their frequency will increase as well. And we know, obviously, at the global level that the increase in temperature mirrors the increase in carbon dioxide, and that has been steadily climbing, particularly over the last 50 or 60 years, and is now moving at a faster clip. So the direction of travel is one way, and as I said before, it's non-linear, and it is accelerating. Of course, as a country, we're not sitting on our hands, and we've got some great architecture in place. We have the Zero Carbon Act, which sets up the Climate Change Commission to give budgets to government to meet in terms of emissions reduction, and that we've got a series of those out to 2050 with a target of heating net zero. We have a national adaptation plan, and we also have our emissions reduction plan number 2 be developed for the incoming government, and there'll be consultation on that next year. So broadly, we have architecture in place, and we're getting on with the job. However, to put that into the global context, if we look at where we need to be and the transformation that is required, we are still well off track. So the targets that New Zealand has signed up to, our nationally determined contribution, is aimed at that bottom line, that's 1.5 degrees, which was the Paris Agreement goal. You'll see from what's demonstrated here is that the currently implemented policies, and they have actually just in the last couple of years started to bring the line down a bit across governments right across the world, are starting to stabilise emissions, but they're an awful long way off where we need to get in terms of the reductions in emissions because of the cumulative effect of emissions into our atmosphere. And you can see in the with the broader colouring in red that there is a high degree of uncertainty about those policies because there are large commitments that have been made that have not yet turned into concrete policy. So there's lots of good intent, and some of the more recently stated intent starts heading us towards that 2 degrees. But every day, every year that it takes us to get on with meeting those commitments, we get further behind because of the cumulative effect of those long-lived gases, particularly carbon dioxide. So I wanted to give you a sense that while we've started the journey both as a country and as a species and a planet, we are a long way off where we need to be. And the radical changes that have to occur across our economies, our production, our consumption, our ways of life over the next 25 years are vast if we've got to have a snowflake's chance of hell of even meeting that 2 degree target. Now, what I think's striking about that overshoot is how marked it is when you put it in the context of the stable climate that we've been enjoying. And if we look over the last 20,000 years since the end of the last ice age and the warming that occurred, sort of started about 18,000 years ago, and when the Holocene began, which is the warm period in which we have enjoyed the last 12,000 years, that was the period that agriculture began. And what you see is a period of relative stability in global temperatures through then. A warmish period after the interglacial or glacial periods that we've been through, but a huge amount of stability and warmth. And it's my contention that that stability was the essential ingredient to enabling agriculture to commence. So the ability to produce annual crops, store grains, be able to use those for feeding people and animals, and beginning to use the seasons and climate and the predictability of that to build not only agriculture, but civilization off the back of it. So it's my contention that the stability of the climate is not what not only underpins agriculture, it is what underpins society. And I think we've often thought about that benign period that we've lived through as being relatively long term and has either always been so, or it was a random accident of history that has enabled civilization to develop. If we step back and we look over the last 500 million years and what the paleoclimate record shows us is that for most of the Earth's history in the last at least 500 million years, CO2, which is the upper graph, has been higher, at lots of periods much higher than it was as we entered the Industrial Revolution. And it did bounce around, and the uncomfortable truth is that when it has peaked historically, it has also coincided with mass extinction events in the fossil record. And so we know that extremes and high levels of CO2 have occurred throughout the Earth's history, have been catastrophic to life, but that they have slowly trended down into recent periods. And so if you look in the middle of that top graph, particularly there is distortion there, obviously, because time is compressed on the left and then spans out on the right. What you can see there is that CO2 bounced around a point, but it actually gets to a period of great stability, particularly over the last sort of 12,000 years, and particularly over that period of relative stability in the temperature and that warmth. And so in the graph below, if you look at the temperature over the same period, last 500 million years, significant amount of variation, but generally warmer than it has been in very recent periods. But then about a million years ago, you get into that period of interglacial, which is cooler than what we've lived through, and then that gradual warming, and then this again over the last 12,000 years of a relatively stable and warm climate. Now, The reality of that for our contemporary circumstance is that where CO2 is going to already on our current track, and where it is will head to without radical transformation of the way in which we produce and consume on the planet, is taking us back into not only uncharted territory in the last 5 million years, which is where we get to once we get well above the sort of 450 parts per million. We're at 420 odd thereabouts today. It starts taking us to places where not only have there been mass extinction events, but where the Earth was a pretty inhospitable place to be for most of the species on Earth today. And so what we start to see here is that the stability that we have enjoyed, that's underpinned agriculture, has been a relatively recent event. It has not always been so on planet Earth. And it has actually come about through the interaction between the atmosphere, the biosphere, and the hydrosphere, and also the Earth's geology over a very, very long period of time. That high level of CO2 that has been present for much of the Earth's history, sequestered away biology and sequestered away into the deep Earth. And so we also, through the cooling period, the glacial period that we've been through, the deposition of ice at the poles. And a few years ago, I had the privilege of traveling to Antarctica and talking to the climate scientists down there. They explained to me that what kept our seasonality and the global climate system in a high degree of stability was the differential that we have with our cold poles and the ice at the poles, and then the relative warmth at the equator. And as we know, our climate is derived of systems, cyclonic systems, and high and low pressure zones that come off the equator and spin off from the poles, and they meet in the zone in which New Zealand resides. And that constant process holds the situation in balance as the Earth tilts backwards and forwards. And so all of that is generated by the polar jet streams going around both the North and South Pole and spinning off the weather. And the climate scientists in the Antarctic described to me what was happening with the weakening of the polar jet. So we see that system is weakening as the poles warm faster than the equator. And we know that at the poles, we see rise much faster than they are at the equator. And so the stability in the system is starting to unravel. And they said to me, what we will see is more cold snaps in summer, warm spells in winter, and the reliability on which agriculture depends and so much of our ecosystems depend starts to unravel with that weakening of the polar jet streams and the weakening of the stability of the systems that come off Antarctica and come from the Arctic down and meet the warmth at the equator. And so what we do start to see here is a system which had developed over a very, very long period of time to not only pull a lot of carbon out of the atmosphere and bring it down to lower levels, but bring it down to lower levels that cooled the planet, deposited ice, and that this whole system was a deeply interwoven system between that biology of the plants and animals on the Earth's surface, the ocean currents, and that deposition of ice and the overall chemistry of the atmosphere. This is something which didn't happen by accident. It happened through the interaction of those systems, regulating one another over hundreds of millions of years to get to a point where human Homo sapiens could reside because of the stability of the climate system, and then ultimately from the stability of the seasonality, build a thing called agriculture and ultimately civilization. So what we start to see here is an interwoven stability, which was a balance. And it happens to be that most Indigenous cultures have been talking about this balance. In Te Ao Māori, it's between Papatūānuku, the earth, and Ranganui, the atmosphere, and those holding the earth are very much in balance. And it turns out, after 400 years of Western science, we're starting to figure out that actually it is an interwoven, interconnected, single system, which is incredibly fragile. And the unfortunate reality of that is as we start to create perturbations in that stability, those perturbations cause more perturbations, and climate change causes more climate change. And we might be seeing examples of this. Many of you will be aware of the Antarctic sea ice this winter we've just been through. The blue line is the most recent graph of that production. The grey lines show the recorded, really over the 50 or 60 years, the recording of Antarctic sea ice as we've been able to do it, has operated within that zone, a high degree of stability. Last year in green, we saw an unprecedented low level, and this year has just dropped off the charts. Now, why that is particularly significant is that sea ice reflects incoming radiation. The less of it, the more we get warming of the dark ocean around Antarctica, and that starts to accelerate other biophysical processes there, whether it be the stability of the ice sheets on the continent of Antarctica and of course, the glacial systems on there, and start to accelerate their movement to the ocean. It also has impacts in terms of the salinity of the ocean around there, with impacts on the upwelling and downwelling of currents, which starts unraveling the stability of the oceanic systems that drive so much of our climate and seasonality as well. So this is one really scary and startling example of what might be the beginning of these really big mega systems simply unraveling from the stability that they give us. And so what's really important for us as we conceive of what lies ahead is to stop thinking that the future looks in. And the reality for the youth of today is that 2100 is not a faraway number that is somewhat abstract. And I think for many of us who are later in life, the notion of 2100 is almost mythical in terms of a place deep in the horizon when some of these worst impacts of climate change are anticipated to occur. Frankly, as is demonstrated here in this pictorial, with the high level of emissions we're currently tracking towards, the intermediate high or very high even, those impacts are coming much sooner than 2100. They're here with us by the middle of the century. But even if we massively decarbonize our energy and transport, and we have a revolution over the next 25 years, and we have that very low emissions scenario, the people living on the planet over the next 80 years will experience a climate that's very different to the one we've experienced. So the future is not going to be anything like the past. And it is true that children who are born today are expected to be well alive by 2100. So this reality is their reality. What does it all mean for us? I thought I'd just note down some things that I think are important for us all to kind of collectively reflect on. The first of it is to check that optimism bias, our tendency to expect that things will work out in the end. You know, when I talk about the science with audience, and even with really informed folk, there's a degree of disbelief. Most of us find it really hard to believe that actually this scenario could be true. We assume that, look, something will come along, something will work out in the end, somebody will fix this, that we'll be forced to make changes. And I'm incredibly optimistic about the uptake of new technology, changes in practice, and there's an awful lot that can be done. And I believe that human beings will make the changes necessary to get on top of this issue. But unfortunately, the physics is such that we cannot now get on top of it fast enough to avoid some of these reasonably cataclysmic impacts of the breakdown in the stability of the climate system. So we will be living with those alongside us as well. So we've got to stop thinking like the future will resemble anything like the past. The only evidence we have before us, genuine, hard biophysical evidence, is going to be very different. And we don't have any evidence to suggest it's going to be anything like the recent past. We're terrible at perceiving change and measuring time as human beings, and there's lots of experiments that have demonstrated this to be the case. We don't perceive change that's happening around us particularly well if it's happening incrementally. And we also underestimate the pace of change. It happens when it's happening quickly. We expect that 2100, even 2020 seems a long way off, seemed a long way off when we were negotiating the Kyoto Protocol, or we were thinking about climate change in 2020. Time moves at a clip and is coming at us fast. We've got to think much more systemically about climate change, how it works through our biophysical systems, through our agriculture, through our land use, water, our biodiversity. And we've got to understand how those compounding impacts have flow-on consequences through our complex biophysical systems, as well as those economic and social systems. All of the challenges we currently have around water security, droughts, floods, etc., how our soil loss challenge, which has been with us for as long as we have cleared forests in Aotearoa, New Zealand, our biodiversity crisis that we have as a country, all of those just get harder from a changing climate. And we've got to expect that we've got those challenges have moving goalposts. One of the things that struck me after Cyclone Gabriel is that we had often prepared for flood events. We had a sense of what we might do in the event of a cyclone once again coming. We had not prepared for a worst case scenario, and Gabriel, in many respects, was a worst case scenario. That complete cut off of Napier from north, south, east, west, losing all of our communication, our power for days on end, the massive impacts on our landscape. Those were worst case scenarios in many respects. They will be much worse in the future, so we need to anticipate and prepare from them, not discount them as improbable or low probability events. We're going to need to obviously have at the heart of our strategies, whether it be our organizational strategies, our business strategies, our economic strategies, how do we build in much greater resilience, redundancy, the ability to withstand shock into both the biophysical as well as economic and social systems. And the way that water, soil and biodiversity works together, and our land use cover will be critical to how we build in resilience to this little country at the bottom of the world. And there is a massive opportunity, obviously, with soils and land use to massively accelerate and maximize, and a huge imperative to do so. One of my recent realizations is it's not a question of mitigation or adaptation. We need to do both at scale and to maximum effort. And it's not a case of do we reduce emissions or go for carbon capture and sequestration. We're out of time. We have to do all of them, and they all have to be done simultaneously with maximum effort, because even if we do all of that, we are in for a terrible ride for the remainder of our natural lives and for the remainder of the century in almost certain terms. And so as a consequence of that, we've got to get past prevarication and debate and indecision about should we use this tool or that tool. We've got to use all the tools, and we've got to use them now. And I do think the question, particularly for agriculture, needs to shift from the how much can we produce at what cost to how much can we withstand by way of drought, of pestilence, of storms of soil loss, etc., while still producing. If our mind shift moves to that, then we'll start to be prepared for what is coming. We cannot rely on global cooperation. There are wonderful pledges. There are great things being done by countries, by companies all across. Fantastic technology that is emerging. But right now, we are peaking. We have the highest level of global emissions on record. We have thousands of aircraft on order. We have new coal-fired power stations being opened, and we have new oil and gas fields being prospected on across the planet. While we are going through this massive decarbonisation and this transition to our economies, we are also going to continue producing vast amounts of greenhouse gases, and many of those will also be coming from systems or processes we cannot now stop, such as fires in the Amazon from droughts from an El Nino, or fires in Australia. The recent fires in Canada are estimated to have produced 1 billion tonnes of CO2 additional to the atmosphere. And there are many other examples of those things which will occur. So those emissions will continue. Global cooperation is fraught. There is a massively unstable geopolitical backdrop that you're all aware of. And so while we've got to keep going on that global cooperation, we can't count on it coming to our rescue. And for communities like Hawke's Bay and for countries like New Zealand, we cannot expect that the cavalry is going to arrive and help us through these increasingly community leadership. Charge of our own destiny will be absolutely critical. And I guess my final point, rounding back to soils, and this is, I guess, is a positive opportunity for New Zealand agriculture and for our producers, is that our soils, our water, what we produce, will only become more precious and valuable through sheer scarcity. And so as they become more precious and valuable, the value proposition, the investment proposition in protecting and nurturing and growing them only continues to grow. And the reward from our consumers will continue to grow as well. I'm confident of that. Some of what you see as market trends at the moment, in my view, are just getting started. Our consumers, our markets, and our social license will orient heavily towards action on climate change to a level that we can't even possibly even perceive right now, as people are seeing in real time all over the planet the catastrophe that we have now wrought upon ourselves. And so I want to kind of put that forward as more of a call to arms. Life on Earth has frequently been very difficult for human beings. We've lived through an extraordinarily benign and privileged period. Unfortunately, that is not the future for us or our children or grandchildren, but we are active, and in Aotearoa, New Zealand, we have extraordinary resources to draw upon. So the work that you are doing today in that room, the work of the Future Farming Trust, the Regional Council, of your industry organisations and supporting you doing what you do, has never been more important. And now is the hour really for us to absolutely lean into these challenges and work faster with more urgency around building more resilience into our food production, into our soils for what comes. So with that, ngā mihi nui kia koutou. Thanks again for the opportunity to speak to you. Hopefully it hasn't been too depressing, but I do want to take this opportunity as the Secretary for the Environment to put the facts in front of people as the science says it is, and not to paper over those and make sure that we are not sleepwalking into things that we could have and should have for the last 40 years, spent much more time and effort getting on with rather than debating. Thank you.